If your research or engineering projects are falling behind, EEprogrammer.com can help you get them back on track without exploding your budget. Let us know what you need. You'll find relief here. Visit EEprogrammer.com. We can help you.
Hello and welcome to Dielectric Videos. On today's episode, we're going to be taking apart and analyzing what is perhaps the worst 18650 cell in existence. This is a presumably brand new GIF brand 9900 milliamp hour cell. Now, just for your own information, the highest value cells you can get on the market today, that is basically the cutting edge cells, are about 3600 milliamp hours. So this 9900 milliamp hour figure is just absurd. Now, to increase the level of dubiousness further, the LG HG2, which is a relatively good modern cell, comes in at about 46 grams of mass. I weighed these cells, and each one comes in at only about 30 grams, so they're much, much lighter in weight than the LG cell. Additionally, the LG cell doesn't sound very hollow, whereas these cells sound like they're just hollow metal tubes. Now, they're not completely useless. They actually are legitimate cells. They have lithium-ion material in them, and they do hold a charge and can be charged and discharged no problem. However, the characteristics that I measured are actually not very good at all. First off, the internal resistance. Now, by comparison, the LG HG2 came in with an internal resistance of 33 milliohms. A cheaper cell from a hoverboard battery came in at 109 milliohms. This one comes in at 296 milliohms, which is double what the cheap, which is actually over double what the cheap cell had. So very high internal resistance. And I did a discharge test on this one, and it came in at an abysmal 521 milliamp hours. So I was thinking when I first started the discharge that maybe this was actually a 900 milliamp hour cell, and they just decided to stick another 9 on to make it a little more ridiculously impressive on eBay. But it's not even a 900 milliamp hour cell. It's probably nominally a 600 milliamp hour cell at best. But I guess maybe there's some application that could use these. They were only about $1.50 a piece, so they're not very expensive. Maybe some kind of like an outdoor LED solar nightlight or solar garden light or something could make use of these. But apart from that, I don't really see that many practical applications. So what I guess I'm going to do next is I'm going to take this one, which I've already discharged completely to 0 volts for a disassembly, outside, and I'm going to cut it open and see what's inside. This is the point where you may want to skip back to my other video where I took apart the LG cell and the hoverboard cell for comparison, so you can see what a good legitimate cell looks like. That way when we take this apart, we can see how different it is in reality. So let's get on and do that. So now I'm going to begin the disassembly. Now before I start, I should emphasize that this is not an experiment you necessarily want to try at home. If you don't properly discharge these all the way to 0 volts, they can potentially start a fire when the cases are punctured. And additionally, the chemicals inside can be somewhat hazardous if not handled properly. So with that out of the way, we can, in this controlled environment, begin disassembling this. And as with the other cells I did before, I'm going to start by removing the top anode side of the cell, and we can inspect to see if there is a PSC in it, or a PTC rather. So I'm going to tighten this down and start rotating it. Looks like it's almost through. There we go, I think. Has that cleared it? Maybe not quite yet. We can get our top part off at least. Let's see if there's any valve or opening underneath this plastic separator. This one, well, yeah, it looks like it has some vents under it. So at least that's, if those really are vents, that's somewhat of a good start. Means it may have overpressure protection. There was a slight hiss. Oh, looks like I'm just turning the... That's interesting. The other cells opened much more easily with the pipe cutter than this one is. I wonder if it's because they were more densely packed inside. Let's just take this sleeve off. There we go. Now it's making progress. Let's see if we can use the wire cutters to make some more progress in there. Maybe go back to the pipe cutter. Yeah, I definitely think this one's harder to open because it's more hollow. There's less, seems to be less densely packed material in it. So it's just sort of crushing the can rather than cutting it. Now we got it. So let's look in there. So doesn't look like any sort of a PTC, so no pressure, temperature, current interrupt. So that means if you shorted this thing out, it would very likely just heat up until it either ruptured or just ran down. Let's have a look inside. So looking inside here, we can already see that there is very little active material when compared to the HG2 and to the hoverboard battery. You see there's a lot of hollow space in there, and it looks like the active material is just sort of loosely padded in. Now it still does have this the smell of sort of sweet acetone bubblegum sort of smell that the 18650 lithium-ion electrolyte is characteristic of, but it doesn't appear as if there's nearly as much active material in there. So I'm going to actually now try and cut the backside off as well. That way we should be able to slide out our active material and see how much there is in the cell. Or just doing that. So that's interesting. It looks like the underside of this has a tape layer around it as an insulator. Let's see if we can just push this out from the top. Will it slide out? There seems to be more, it seems more wet with electrolyte than the other cell did. The other cell was very, it didn't really start showing a lot of electrolyte until I had actually pulled it all the way out. No, I may have to peel this case back as well, just like the others. There it goes. Now it's coming out. So here's our active material, and as I noticed before, it has some tape holding it in place. This part still has some heft to it. I think the case is thinner as well. It's not just the lack of active material that makes it lighter in weight. So we'll take the tape off there, and let's see if we can unravel this and see how much stuff there is. Oh yeah, this thing is just soaked in electrolyte. Look at that. Similar in construction to the other cells with the separator, but look at that. We've got like maybe a foot and a half of active material, and that's it. And this stuff looks pretty nasty. I mean, it's got this almost rainbow effect, this iridescence to it. Makes it look kind of like it was either really low quality material or just the application was not very effective. So I think more than anything though, just the sheer small amount of active material is indicative of why this thing has such poor performance. It's very thick, just like the hoverboard battery. It's not thin like the LG cell. Which I guess doesn't really matter because they're not trying to cram very much into this can, but it's still pretty low rent compared to the actual professionally built high-end cells. Separator is about the same type of separator as what we found in the hoverboard cell, so nothing too special about that. But yeah, there you have it. 9,900 milliamp hours. I doubt it. Well, anyway, thanks for watching dielectric videos, and I will see you next time.